We are in the penultimate problem, that's question number 19. It's finding trigonometric ratios. Here we have been given a triangle and they have told us to find the six trigonometric ratios. Let's write what are known. This is 90 degree or the right angle. That means the opposite to it is hypotenuse. Hypotenuse. And then what do we have? Theta is known, so opposite to is opposite side itself. And then the next side to it, other than the hypotenuse, is called the adjacent side. So adjacent side. All three done. Now here, we don't know the adjacent side. We know only opposite and hypotenuse. Since trigonometric ratios are given as sine, cosine, and tan, we can remember this acronym SOHCAHTOA. SOHCAHTOA. So SOHCAHTOA. It's sine theta equals opposite by hypotenuse. Whereas cosine over here, theta is equal to adjacent and hypotenuse. Adjacent divided by hypotenuse. And lastly, tan theta is equal to, this is opposite by adjacent. So these are the three formulas. Now, once we know these formulas, we can easily substitute. Over here, see, we have opposite side by hypotenuse is 13. But what about the adjacent side? That's missing, right? We can find it. Now here, this is a right angle. If you remember the Pythagorean triplet, I can directly write this as 12 because 13, 5, 12, 13 is Pythagorean triplet. But if not, how would you solve this? Is hypotenuse. See, hypotenuse, the whole squared, will be equal to the sum of the other two sides. That is adjacent squared plus opposite squared. This is the formula of Pythagoras, right? Hypotenuse is the square. Hypotenuse squared is equal to sum of the square of other two sides. Now hypotenuse is 13 squared equals adjacent is x, that is unknown because this was supposed to be unknown, right? Adjacent squared plus 5 squared. Now you can put this in the calculator directly. Now here it will be 169 and 25, so it will be 169 minus 25, it's 144. And we know the square root of 144 is 12. But still, we will just use the calculator directly because it's electronic part. You don't need to write anything. X squared plus 5 squared, shift and solve, and then equal to it's 12. So once we have found all the sides, we can find the trigonometric ratios. Here it is 12 by 13. Then last we have 5 by 12. So these are the trigonometric ratios of sine, cosine, tan. And then there are 6 they are mentioned. Which are these? The reciprocal identities. I'll write the formulas here. The reciprocal identities are secant, I'll write down over here, secant theta, SEC that is, and cosecant, CSC theta, and cotangent theta. Now these are all given by very simple formulas. 1 by secant is 1 by cosine, cos theta. Whereas this is 1 by sine theta, and lastly we have 1 by tan theta. So now here, remember, if secant is up over here, it's, S is, if S is there, that's secant, you can't have sine. It should be other than that, cosine. If it is cosecant, it will be sine. So remember, don't get confused, it's sine and secant. No, it is secant and cosine. They're inverse of each other. So I don't need to write the formula or anything. So now let me start with secant. Secant theta will be just the inverse of this, cosine's inverse, because it's 1 divided by, right? So 13 comes up divided by 12. Now what about cosecant? That is given as 13 by 5. And lastly, cotangent is 12 by 5. The formulas are just the inverse of this. Adjacent goes up, opposite comes down, and so on over here. So that's how we find it out. Now in your exam, you'll have all these 6 trigonometric ratios as your options, isn't it? Just try to check sine, cosine, tan and check which is the correct option. Might be only one option will have these correct formulas, so that's your option, You do not need to even find the other ones. But if there are 2 options with all these correct values, then yes, you need to see which is the inverse of these, then you can easily select the correct one. So here you can see these are the correct answers. Similarly, you can do the other problems by yourselves. Now I'll just write this is hypotenuse and this is theta, so this will be opposite and the other side will be adjacent. Please do these problems in you can do it in any way, but you need to solve at least sine, cosine and tan, and then you can find the other trigonometric ratios. You solve it and then check the answers. Similarly, this one as well. Let's write what do we know here. This is hypotenuse, and then this is opposite, and adjacent is missing. And then you just put in the trigonometric ratios, and then you get the answers. And here as well. Now, yeah, here also they have given the hypotenuse is missing, whereas we have the opposite 45 and adjacent is 24. So we need to find the hypotenuse by the Pythagoras theorem, and then we find this trigonometric ratios. Here as well, there is no difference in this. Let's look into some different type of problem. Here as well, it's the same one. Okay, this one now. They have given us tan A equals 8 by 15. So we know there is a triangle, because trigonometry is it's a right angle triangle. Okay, this is 90 degree and this is hypotenuse. And now I can consider any side to be A. I can consider this as A or this. If I choose this, then theta is over here. Then this is B and C. And now which will be opposite? So opposite side is this one, but what is tan theta formula? It's opposite by adjacent. So I know the opposite side is 8 and adjacent is 15. And hypotenuse is unknown. If I had written over here theta as A, then this would be opposite adjacent. The answers won't change. It will be the same thing. Okay. So now let's find the other side. How do we find the other side? It will be hypotenuse, the whole squared will be equal to 15 squared plus 8 squared. This is what we are solving for. So we can just put in the calculator and get the answer. Here we can directly take the square root on both the sides. So I'll write square root 15 squared plus 8 squared. The answer is 17. Why? Because I need hypotenuse only, not the square. So imagine this is x, it's x squared, right? Take square root on both the sides, it will be 50 square root of 15 square plus 8 square. And here we have this as 17. Now then we can write sine theta is opposite by hypotenuse. That means opposite is given over here. I'll write it as opposite, and this is adjacent. So opposite is 8 by 17, and then cosine theta is adjacent by hypotenuse, and that is given as 15 by 17. And we know tan theta already. Now we can consider this to be theta, it's fine, okay? Or you can write it as ABC. Tan theta is equal to opposite by adjacent, that is 8 by 15. So that's the answers. And then the sine, the secant, cosecant and cotangent are just inverse of these. So you can see here they have found the value of the hypotenuse, that's 17, and then the trigonometric ratios here 8 by 17, 8 by 15. Now this is tan, and this is, where is cosine? Over here cosine. Now what is the inverse of sine? It is cosecant. So you can see it's just flipping this, 17 by 8. And what about secant? Flip this, cosine, it will be 17 by 15. Lastly, tan and inverses, cotangent, that is 15 by 8. Similarly, you can solve for the others. Now, in this case, what happens is if you consider this A as theta, you know the opposite is unknown, adjacent is known and hypotenuse is known. So this is 90 degree, 10 and 3. Then you solve for A, and then you find the trigonometric ratios. Now here as well. Now what happens if you don't have a denominator? In this case, just take this as divided by 1. So in the diagram, now B is the theta, opposite is 3 and adjacent is 1, then hypotenuse needs to be found out. Over here, just put in the calculator and find it out. Remember, when we take square root, it's plus or minus, right? But we take only the positive value because it's a number, it's a value we need to consider. So similarly, we can solve the others. Okay, they're all same. Even over here, these are the answers. Please solve them by yourselves and then look for the answers. There's nothing difficult in this. And over here, I'll just draw a figure over here quickly. You can just draw a right angle triangle. Then you choose. I'll choose this as A now. If that is theta or A. Opposite is 15, that is opposite side. Hypotenuse is 17, and this adjacent will be missing. So you just put in the calculator, you'll get the adjacent, and then you can find the trigonometric ratios. So here it's 8, and then you just write the values for the trigonometric ratios. And that's the end of question 19. It's a simple one. Just remember the trigonometric ratios formula. You can remember SOHCAHTOA to remember it. And then also we must use Pythagoras theorem to get one of the missing sides.